So we previously have used trigonometric identities to reduce uh, trigonometric expressions. And so just as a refresher, here are the identities that we've used. Now actually there are a whole bunch more, but for this course these are the only ones that we will be using. And these are the main ones. There are some other ones that can be really helpful in looking at the unit circle in other ways, and the trig for that matter in other ways. But for us, that's just going to take more time to go through that. So if you have the opportunity to get to look at that on your own, it's definitely worthwhile. But these are completely new and will be helpful. So when we verify trig identities, we're going to have something like this, and it's going to say that secant squared of theta minus 1 over secant squared of theta is equal to sine squared of theta. What we need to do is to prove this. So this is not like solving an equation where, oh, I can multiply both sides by secant squared of theta. No, this is, we leave one side completely untouched and we manipulate another side. This is how we work with mathematical proofs. So you probably have done proofs before in geometry. It's the same way. So it's almost like we don't know what this is, so we want to try and simplify this. However, we're given what the answer is. That's more or less what this is. So make sure you leave one side of the equation untouched. So what we do is we refer back to our identities, and here we see secant squared of theta minus 1. Well, that's probably one of the Pythagorean identities, and it is. So we know that 1 plus tangent squared of theta is equal to secant squared of theta. But I have secant squared of theta minus 1. So what I do is I subtract 1 on both sides, and I get secant squared of theta minus 1 is equal to tangent squared of theta. And so now I can substitute in the numerator and say, all right, tangent squared of theta over secant squared of theta. Now I'm gonna spread this out. I'm gonna write this as division. So we could actually say tangent squared of theta divided by secant squared of theta. And so tangent squared of theta, that we can write as sine squared of theta over cosine squared of theta. And secant squared of theta, so this is times 1 over, whoops, got ahead of myself, times 1 over secant squared of theta. So I have sine squared of theta over cosine squared of theta, and I'm going to multiply, because 1 over secant squared of theta, that is cosine squared of theta. The cosine squared of thetas cancel out, and so I'm left with sine squared of theta equals sine squared of theta. Done. So one process where a lot of people will get confused is right in here. And so where people will make the mistake is when they say, oh, divide it by secant squared. And they think, well, that's cosine squared. And then they mix the step of the reciprocal and the cosine, and they do times 1 over the cosine. So they try to do too much in their head at once, and they miss exactly what they need to go for. So notice, yeah, I knew that this was 1 over cosine squared, but I still changed this division first. So if you write out each step, you won't run into as many mistakes. So here are some more examples, and so we're going to go through these and again treat these like proofs. So tangent of x divided by secant of x is equal to 1 over sine. So just like before, I'm going to write this as division. So this is tangent of x divided by secant of x. I didn't do anything here yet, but now I am. I'm going to say, all right, tangent of x, well, that's sine of x over cosine of x. And secant of x is times 1 over secant of x, because I'm dividing by secant of x, so this is times 1 over secant of x. So So then this is sine of x over cosine of x times, because 1 over the secant of x is cosine of x. So then they cancel out, and I get sine of x is equal to sine of x. And I am done. Cotangent and secant, hopefully you're starting to see a pattern. Cotangent is sine and cosine, secant is 1 over cosine. So cotangent, that is actually cosine of x over sine of x, times secant of x is 1 over cosine of x. And this is going to be divided by cosecant of x is actually 1 over sine of x. Cosine of x cancel, so I get 1 over sine of x divided by 1 over sine of x is equal to 1. And so here you can see, you can work this down and multiply, but really as soon as we see we're dividing something by itself, in this case 1 over sine of x, we know that's just 1. So we get 1 is equal to 1. Here, tangent, sine, cosine. So this is equal to secant. Oh, I think this is actually a hard one. Yeah. So I actually haven't done these yet, but I remember them from previous years. Yeah, this is a really, really good problem. I'm actually going to come back to this one. So let's do 4. Let's do 4, and then I want to spend some time talking about number 3. So number 4, we can look back at our Pythagorean identities because we see those square values. So we see that 1 plus cotangent squared is equal to cosecant squared. So this cosecant squared I can substitute in, so I get cotangent squared of theta minus 1 plus cotangent squared of theta is equal to -1. This just cancels out, so I get cotangent squared of theta minus 1 minus cotangent squared of theta, distributing in that negative, and cotangent squared of theta minus cotangent squared of theta is equal to -1. Okay, this is a good one. So we're going to make this sine of x over cosine of x times sine of x over 1 plus cosine. I changed the variables for some reason. We'll keep them as thetas. All right. So here, nothing can cancel out. So this isn't a trick. So actually what I need to do is I need to multiply. So I get sine squared of theta over cosine of theta plus cosine of theta over 1. I'm adding, so I can't cancel these out. You know, it's not going to make sense. I can't cross-reduce because I'm not multiplying here. So I'm adding fractions. So when I add fractions, what I need to do is I need to multiply to get a common denominator. So I multiply by cosine theta over cosine theta. So I get sine squared of theta over cosine of theta plus, that's a plus, cosine squared of theta over cosine of theta. Sine squared of theta plus cosine squared of theta is a Pythagorean identity. That is 1. The denominator stays the same. 1 over cosine of theta is equal to secant of theta. That was a fun one. So you need to be careful. Don't always think that, oh, I'm multiplying and common factors are going to cancel out when I cross-reduce. No. I mean, that is true, but here, this is addition, so we can't do that. And here, it's not a mistake, like, oh, I should have flipped this. No, this is 100% correct. So you need to remember that these are fractions, and you can add fractions. So these trigonometric functions work the exact same way as any numerical fractions will work. All right, so here are some more problems. So Yeah, let's just go through these. So what I'll do, give myself some space here. All right, let's go through these. So the first one, tangent of x plus sine of x plus cosine of x is equal to secant of x. Well, wait, that's one we just did, right? Sine of x, tangent of x, yeah, that's, so we just, see previous slide, we just did that one. I think I put that on here to see if anybody in class is paying attention. Excuse me. Over here, cosine squared of x. When we see this, something's going to be happening. So what we're going to do is we're going to substitute in 1 minus sine squared of x, because we know that cosine squared of x plus sine squared of x is equal to 1. So cosine squared of x is equal to 1 minus sine squared of x. Distribute this in, we get sine of x minus sine of x plus sine cubed of x. These two cancel out, so we get sine cubed of x is equal to sine cubed of x. This is actually something similar we did in a previous lesson. Here, yet again, we can see we got some fraction work there, so that's going to be some fun stuff. This is the key. So we could do tangent square root of x over tangent of x, but this is the key. Seeing that we get a sine and a cosine. So what I'm going to do, I'm going to change this all around. And so this is, well, I'll do this one step at a time. I'll make this a cotangent of x, and I'll make this sine of x over cosine of x. So cotangent of x, that's going to be cosine of x over sine of x plus sine of x over cosine of x. Common denominator here is going to be sine of x cosine of x. So I multiply this by sine of x over sine of x, and I multiply this by cosine of x over cosine of x. So I get cosine squared of x plus sine squared of x over sine of x cosine of x. And that numerator hopefully looks like our identity. It is a Pythagorean identity, which is equal to 1. So we get 1 over sine of x cosine of x is equal to 1 sine of x, or 1 over cosine of x sine of x. So some good problems there. We have something similar here. So we have 1 plus sine of alpha. Oh boy, this this is one I remember. And we get 2 secant of alpha. So sometimes it helps to think about what secant is. And the secant is 1 over the cosine. So if we want to try and aim to get this to be 1 over the cosine, or 2 over the cosine. So what I could actually do, see this fraction here? I'm going to multiply this, and I'm going to multiply by 1 minus sine of alpha over 1 minus sine of alpha. Now, some of you are probably thinking, where did I get that from? Well, look at actually what this is. 1 minus sine of alpha, 1 plus sine of alpha. Those are conjugates And when I multiply conjugates, I get a difference of 2 squares. So I get 1 minus cosine, sorry, 1 minus, getting ahead of myself, 1 minus sine squared of theta. Because this is, you could multiply this out as a binomial, so you can multiply this out, but you're still going to get a binomial squared. These are conjugates. They get a difference of 2 squares. In the numerator, yeah, I can multiply this out. Actually, no. So I'm not. I'm going to do cosine of alpha times 1 minus, oops, 1 minus sine of alpha. So notice there, I didn't distribute in that cosine. I didn't do anything with the numerator. I just said, hey, I'm multiplying these. And the reason is 1 minus sine squared of theta, that is a Pythagorean identity. That's cosine squared of alpha. So now you can see that what we got is that cosine over cosine squared reduces to just 1 over cosine. So I get this. And so now common denominator just fell onto our laps. So we have 1 minus sine of alpha plus 1 plus sine of alpha. 1 plus 1 is 2. The minus sign plus sign cancel out. So I get 2 over cosine of alpha. And 1 over the cosine is secant. So I get 2 secant of alpha is equal to 2 secant of alpha. That was a fun one. Really challenging though. So if that really confuses you, don't worry too much. I mean, this is definitely one of the more challenging ones we will have, but it's nothing impossible, because you should realize that really seeing this cosine, you want to try and make this cosine. Seeing this, you multiply by the conjugate pair to get 1 minus sine squared, which is cosine squared, and so that's going to cancel out with this. So we're just going to get 1 over cosine. So that's some good stuff there, but really the key with any of these is just knowing these identities. These are actually nicer than our previous units because they actually show you what we're going to get in the end. You just need to fill in the gap.